I hope you find this video to be helpful. I'm going to go over the Module 7 Unit 2 review. So you might want to print the review and have it handy. You can work the problems as I work them, or you can pause this and see if you can do it on your own, but here we go. The first 3 questions ask about domain. And, Number 1 says, what's the domain if the function, the rational function, is x squared minus 30x over 5x? Well, what we need to worry about with domain is the denominator, and that cannot be 0. If I solve this now, divide by 5, x cannot be 0. In my math lab, it will have a sentence for you to fill in, and it will say that the domain is the set of all x's such that x is a real number and x cannot equal, and then there will be something for you to fill in. And that's where you'll fill in the value you get here, which is 0. Okay, let's try number 2. All right, problem number 2. Still a domain question. If f of x, the rational function, is negative 4 over 7x plus 2, what's the domain? Well, we find the domain restrictions by taking the denominator, 7x plus 2, and saying it can't be 0. Solve this inequality just like you would an equation. I have 7x cannot equal negative 2. Divide by 7. X cannot equal negative 2/7. And I'm not going to take video time to write out a sentence like this again. There will be one, and you will fill in the value that x cannot be. Whoops, that was a little dramatic. All right, problem number 3. This is the last of the domain practice questions. It says if f of x is 6x minus 9 over x squared minus 16, what is the domain? Well, we know that the denominator, x squared minus 16, cannot equal 0. This is quadratic. And the product of these cannot equal 0. That would be x plus 4 times x minus 4, because this is the difference of squares. That means that either x plus 4 is the factor that can't be 0, or x minus 4 is the factor that can't be 0. So x cannot be, negative 4, or x cannot be, we'll add 4 to both sides. This is not coming out very well. 4. When you fill this in, you'll have the sentence, and it will say x cannot be, and you will have negative 4, comma, positive 4. And it doesn't matter what order you put the two answers. All right, the instructions change. Starting with numbers 4, 5, 6, and 7, it says to simplify the rational expression. Now, simplify means to reduce. We're going to factor the top and the bottom and see if we can divide out any common factor. Number 4, I have 7x minus 21 over 4x minus 12. I can factor the numerator. There's a common factor of 7. That will leave me with 7 parentheses x minus 3 when I divide 7 out of each of those over 4 parentheses x minus 3. I now have, let me get to my highlighter. I have a common factor here and here that I can divide out, and that leaves me with a simplified version, 7 over 4. Number 5. I'm still supposed to simplify or reduce. I have 8 minus x over x minus 8. I hope that you recognize immediately that these are opposites. You can divide out opposites, but when you do, you're leaving a negative behind. So this will equal negative 1. Always notice if they are opposites. Number 6, still reducing. I have 3x plus 3 over 15x squared plus 24x plus 9. If I'm going to reduce, I have to factor. The numerator factors into 3 parentheses x plus 1 over. The denominator, I see a common factor of 3. If I take the 3 out, that will leave me with 5x squared plus 8x plus 3. And then let's see if I can factor that a little bit further. Keeping the 3, if I have a 5x and a 1x, and I have plus 3 and plus 1. The factors of 5 are 5 and 1. Factors of 3 are 3 and 1. I'm testing this. The outer product is 5x. The inner product is 3x. Those add up to be 8x. So this has become 3 times x plus 1 over 3 times 5x plus 3 times x plus 1. What do you see as a common factor? Well, I see the 3's, those divide out. I see the x plus 1's, those divide out. And although sometimes I don't write them all down, when you divide something out, you're leaving little 1's behind. That means that in the numerator, you have 1 times 1 is 1. In the denominator, all you have is 5x plus 3. All right, number 7. This is the last of the simplify. It has x to the third minus 27 over x minus 3. To reduce or simplify, I need to factor first. The numerator, I hope you remember, difference of cubes. Difference of cubes has a little parentheses and a bigger parentheses. In the little one, I get the cube root of x to the third, which is x. I keep the sign, which is minus. The cube root of 27 is 3. Now, to build the trinomial, I square. X times x is x squared. I change the sign. I don't know why that keeps jumping. Plus product, 3 times x is 3x, square, x times 3 times 3 is 9. It's over x minus 3, which can't be factored. Dividing out my common factor of x minus 3. That leaves a 1 on the denominator, but I don't write denominators of 1, so my answer will be x squared plus 3x plus 9. In or out of parentheses, it shouldn't matter. Starting with 8 and 9, I'm going to find products. Multiply. All right, problem number 8. I have s squared minus x squared over s plus x times s over s squared minus sx. All right, I'm going to factor the locations. I'm going to start with the numerator of the first fraction. I have difference of squares. Whoops, and I just accidentally opened PowerPoint. My wrist is sometimes hitting this. All right, I have s plus x times s minus x. In the bottom, I just have s plus x and it can't be factored. The numerator of the second one, I just have an s. The bottom, I have a greatest common factor of s, and if I factor an s out, it will leave me with an s, and here it will leave me with a minus x. All right, I have quite a few common factors, so I can divide them out. This s with this s minus x with this s minus x, s plus x, s plus x. It appears as if everything has canceled out. A better word for that is everything has divided out, which means I have 1 over 1, which is 1. The product is 1. Number 9. I have x squared plus 12x plus 35 over x squared plus 14x plus 45 times x squared plus 9x over x squared plus 5x minus 14. Because it's multiplication, I have to factor everything. I'm going to take care of the numerator of the first fraction first. Trial and error. The last sign is positive. That means either plus plus or minus minus. This says they're plus plus. I am sorry, I am just touching way too many things on here. So I'm going to have factors that multiply together to give me 35 but add up to 12. So that is 7 and 5. The denominator. Both signs are pluses. I'm going to have an x and an x. Factors of 45 that add up to be 14. How about 9 and 5? The numerator of the second fraction. It's a binomial and there is a common factor of x. So x times x plus 9. The denominator, be a little bit careful because there's a minus sign. That means that I need 1 plus and 1 minus, x and x. I need factors of 14 that have a difference of 5. So how about 7 and 2? And the 7 needs to be positive. All right, let's see what we get to divide out. I have an x plus 7 and an x plus 7. I have an x plus 9 and an x plus 9. I have an x plus 5 and an x plus 5. That leaves me with an x over x minus 2. All right, in the review, starting with, in fact, only with number 10, it is a quotient. That means it's division. So I have x squared minus 6x plus 9 over 2x minus 6 divided by 5x minus 15 over 10. Division, keep, change, flip. So I've got x squared minus 6x plus 9 over 2x minus 6 times, flip the second fraction, 2 over 5x minus 15. Now that it's a multiplication problem, I'm going to factor everything. The numerator, it is x minus 3 times x minus 3. And you could write that as x minus 3 to the second power if you wanted to. The denominator has a GCF, greatest common factor, of 2. 2 times x minus 3 times 10 over 5 is a common factor. If I factor out a 5, that will leave me with x minus 3. It's a little hard to read this. That is minus 15. There we go. All right, what can I divide out? Well, I have an x minus 3 and an x minus 3. I have an x minus 3 and I have an x minus 3 over here. I have 2 goes into 10 5 times, but I have a 5 and a 5. And that doesn't want, there we go. So I've divided everything out, and every time I divide something out, I'm leaving a factor of 1, so I get the quotient of 1. Problems 11, 12, and 13 are addition and subtraction. So I'm going to need to get common denominators on these. So these will be add or subtract. Problem 11. I have 6 over x plus 4 minus 3 over x minus 4. I need to get a common denominator. The LCD will be one of every different kind of factor. Now I can't factor x plus 4 and I can't factor x minus 4. They are each factors, so my LCD is their product. So I will now rewrite these fractions both over the LCD. And I do some comparing. I compare the old denominator to the new and say, hey, what's the new factor? And it's x minus 4. Multiply that times the top. So I get 6 times x minus 4. So that the top and the bottom have been multiplied by the same thing. Second fraction, compare. What's the new factor? X plus 4. So multiply the top. So that'll be 3 times, well, let me do that in black ink, 3 times x plus 4. All right, now that I have a common denominator of x plus 4 times x minus 4, I'll just bring all of this down. Distributive property here. 6 times x is 6x. 6 times negative 4 is negative 24. This negative sign right here belongs to the 3. So it is a negative 3 getting distributed. So it is negative 3 times x is negative 3x. And be careful here. It is negative 3 times 4, which is negative 12. Combine like terms. I have 3x, I have 6x minus 3x is 3x. Negative 24 and negative 12 makes negative 36. The bottom is x plus 4, x minus 4. You can factor the numerator because there's a common factor of 3. And that would give you 3 parentheses x minus 12 over x plus 4, x minus 4. But that does not give you any common factors to reduce. So you may go back and say, never mind, that factoring of the numerator did not help me reduce it. You always have to check and see if you can reduce it. So there is that entire problem. This would be counted correct, and this would be counted correct. You only factor the numerator hoping that you will get to reduce. Okay, let's look at number 12. Adding and subtracting still. I have 5x minus 11 over, over 2x, no, I keep wanting to put a 2 there and it's not there. X squared minus 2x minus 35 minus parenthesis, no, just 4x minus 4, x squared minus 2x minus 35. Well, this problem already has a common denominator. It's not factored, but it is a common denominator, so I could just say that's x squared minus 2x minus 35, same denominator. But when I bring these two down, this numerator and this one comes down with no problem. But this negative sign needs to affect both terms of the top. So this is going to be a negative 1. It's, oh goodness. Well, things are kind of messing up a little. There we go. It's going to be a minus 1 times 4x, which is minus 4x. It's going to be a minus 1 times a minus 4, which is plus 4. Combine your x's, positive 5 and minus 4x is x. Combine your constants, negative 11 and positive 4 gives me negative 7. Now generally my denominator is factored. This time it isn't, but I need to go ahead and factor it to see if I can reduce. This will be x minus 7 over. Like I said, it's unusual that the denominator is not factored, but we already had a common denominator, so we'll factor it now. 1 factors plus, 1 is minus. Factors of 35 with a difference of 2. How about 7 and 5? And we see that x minus 7 is a common factor. Remember that little ones are left behind. That leaves us with 1 over x plus 5. All right, we have one more in the addition-subtraction category. Number 13. I have 8 over 3x minus 27 plus x over x squared minus 2x minus 35. To get a least common denominator, I need to see factors. So this denominator has a common factor of 3. It's 3 parentheses x minus 9. I don't need that version anymore. This is a trinomial. Well, I don't know why that's jumping. So I have 1 plus, 1 minus, x. Oh my goodness gracious. I am sorry, things are jumping here. I have x and an x. I need factors of 35 with a difference of 2. It's going to be minus 7 and plus 5. The common denominator here, and you know what? I copied down the problem wrong. So, this is my bad. This second denominator is merely x squared minus 81. I thought that looked familiar, and it's because I copied down this denominator right here. Okay, so 13, if you copy down the problem right, this is the difference of squares, x plus 9 times x minus 9. The LCD is going to be, I need a 3 from here, I need an x plus 9, and I need an x minus 9. So let's make these denominators. 3 times x plus 9, x minus 9, 3, x plus 9, x minus 9. Compare. Look at the old denominator, look at the new denominator. We see a new factor of x plus 9, so multiply the top by it, and we get 8 times x plus 9. Whatever is new in the bottom needs to also be new in the top. Let's compare over here. The only thing that is new is a 3. So we'll multiply a 3 times the top also. So that becomes 3x. Now I have a common denominator, one fraction, 3, x plus 9, x minus 9, and I'll use the distributive property here. 8 times x is 8x, 8 times 9 is 72. I have a plus here, plus 3x. Combining like terms, I have an 8x and a 3x added together for 11x plus 72, and it's over 3 parentheses x plus 9 times x minus 9. That numerator cannot be factored, therefore this answer can't be reduced, and it's finished. All right, next group of questions in the review say to solve the equations. When you're going to solve equations, you're going to multiply by the LCD. Not put them over the LCD, but multiply. So for number 14, I have 5 minus a over a, and I'm going to spread this out, plus 3 over 4 equals 7 over a. Looking at the denominators, the common denominator, the LCD, is 4a. So in red, I'm going to multiply the first fraction times 4a, the second fraction times 4a, and the right side by 4a. Every term needs to be multiplied by it. In this first group, the a's, oh my goodness, the a's divide out, and you are left with 4 parentheses 5 minus a. No denominator anymore. In the second group, and this only works when it is equations. Second group, the 4's divide out, and you are left with 3 times a, and it's positive. Equal sign. The right-hand side, the a's divide out, and you're left with 28. All right, let's solve this equation. 4 times 5 is 20. 4 times negative a is negative 4a, plus 3a is equal to 28. Combining my like terms, I end up with keeping the 20 minus a single a is equal to 28. That was negative 4 and positive 3. So I'm going to now subtract 20 from both sides. I have negative a is equal to 8. Divide by negative 1, and a is negative 8. Now hopefully you remember from our study you have to check your answer to make sure it does not cause a domain problem in the original equation. Well, if a is -8, that does not become 0. That never becomes 0. And this a does not become 0. So this is a valid answer. By the way, this review is longer than the test by quite a bit. We just want you to have lots of practice. Number 15, still solving an equation. I have 2 over t is equal to t over 5t minus 12. This particular equation is, jumping around, is a proportion. Proportions can be solved by looking at, the cross product. That product times that product. All right, let's look at this one. I'm going to have 2 parentheses, 5t minus 12. The other product is going to be t squared, t times t. This is going to be a quadratic equation because of the squared. Distributive property on the left. 2 times 5t is 10t. 2 times 12 is minus 24. That equals t squared. Because it's quadratic, I need it equal to 0, and I'm going to subtract 10t from both sides. And in the same step, I'm going to add 24 to both sides. That leaves me with 0. That's what I wanted. T squared minus 10t plus 24. Because it's quadratic, I'm going to try my factoring skills. I need a t and a t. Last sign is positive. That's either plus plus or minus minus. Because the middle is minus, it is minus minus 6 and 4. Set them equal to 0. T minus 6 equals 0, or t minus 4 equals 0. That's back from chapter 6. So t is 6, or t is 4. Let's see, we do need to check, does either of those cause a domain problem? Look back. 6 won't make either denominator become 0, and positive 4 won't make either denominator become 0. So these are fine. Last one. Number 16. I'm going to space this out. I have 1 over x plus 7 plus 2 over x plus 3 equals negative 4 over x squared plus 10x plus 21. Still in equations, still going to multiply everything by the LCD. I know that the denominator will need an x plus 7, it will need an x plus 3, and let me look at this. If I factor this, I'm going to have a plus and a plus, x and x, factors of 21 that add up to be 10 are 7 and 3. I don't need that version anymore. That means that the LCD is indeed x plus 7 times x plus 3. All right, I'm going to take a little shortcut, and I'm going to write x plus 7 times x plus 3 here, x plus 7 times x plus 3 times that one, and finally x plus 7 times x plus 3 there. I get to do this because it is an equation. First one, x plus 7's divide out, and you are left with 1 times x plus 3, which is x plus 3, plus the x plus 3's divide out, and you are left with a 2 times an x plus 7, equal sign. In the last fraction, the x plus 7's divide out, the x plus 3's divide out, and I am left with -4. So I need to solve this equation. I'll keep my x plus 3 plus distributive property. 2 times x is 2x. 2 times 7 is 14. That equals -4. Combine your x's, 3x. Combine your constants for 17 is equal to -4. Going to subtract 17 from both sides. That gives me 3x is equal to -21. Divide by 3, and x is -7. But because it is a rational equation, we always have to check there is a domain to worry about. If x is -7, what happens to this denominator? Oops, it goes to 0. I don't even have to check anything else because all I have to do is have one of these fractions blow up with a domain problem. If x is -7, this becomes 1 over 0, and you can't divide by 0. So you would say, nope, there is no solution. Okay, that's it for the just plain solve equations. The next part are the word problems. And the instructions say solve. So you will get equations to solve. Hopefully you're looking at the printed copy. I will read them. It says, if 3 times a number added to 7 is divided by the number plus 8, the result is 4/3. Okay, so x is the number. If 3 times a number, 3x, added to 7, plus 7, if that is divided by the number plus 8, the result is equal sign 4/3. All right, I feel pretty good about this because I got a proportion. So I can do cross products. One of them is 3 parentheses 3x plus 7 is equal to 4 parentheses x plus 8. Distributive property on the left, that's 9x plus 21. Distributive property on the right, 4x plus 32. I have x's on both sides. I choose to subtract 4x. That gives me 5x plus 21 is equal to 32. Going to subtract 21 from both sides. I have 5x is equal to 11. Divide by 5. It doesn't go in evenly, and I think Math Lab will tell you to leave it as an improper fraction. You'll need to read the instructions. 11 over 5. If it wants a mixed number, you will divide and get 2 1/5, but I don't think it will want that. Number 18. 18 is a work problem. I set up work problems differently than the author of your book does. I always have each person or machine working makes up a fraction, a part of the job, and together they do the whole job. And it is always their alone time on bottom and their together time on top. All right, so together over alone for each one of them. All right, I will read number 18. A painter can finish painting a house in 8 hours. That is the painter's alone time. Her assistant takes 10 hours to finish the same job. So the assistant's fraction, her alone time is 10 hours. How long would it take for them to complete the job if they were working together? X is together. So X here and X here. And this is my equation to solve. Common denominator for 8 and 10 is 40. So I'm going to multiply 40 here, 40 here, and 40 here. Eight goes into itself once and it goes in there 5 times. That leaves me with 5x plus 10 goes in there once, 10 goes in there 4 times. That leaves me with 4x, and that equals 40. Add them for 9x is 40. Divide by 9. X is. Now, it depends on what my math lab wants. With the work problems, it usually wants a mixed number. So I will have to divide 9 into 40, and I don't want a decimal. And so it's going to go in there 4 times. That's gone. That is 36. Subtract for 4, and that will be a remainder of 4/9. 4 and 4/9 hours. But check what MathLab asks for. I think it will want mixed numbers. All right, last work problem is 19. And remember, the test is not this long. It says one conveyor belt can move 1,000 boxes in 6 minutes. All right, we've got conveyor belts. In fact, I just glanced and we have 3 conveyor belts. Okay, one can move the 1,000 boxes, which is the job, in 6 minutes. That's his alone time. Another can move 1,000 boxes in 9 minutes. That's the second conveyor's alone time. If another conveyor belt is added and all 3 are used, that means we're talking about together. The boxes are moved in 3 minutes. 3, 3, 3. How long would it take the third conveyor belt alone to do the same job? This time, X is the third belt's alone time. Now, if you want to, this problem is easier if you notice that these can be reduced. You don't have to. But if you reduce this to be a half, you reduce this to be a third, this is still 3 over x is equal to 1. The least common denominator needs a 2, a 3, and a x, which means it needs 6x. It will be bigger if you don't reduce, but the answer will turn out to be the same. 2 goes into itself once, 2 goes into the 6 3 times. I have 3 times x times 1, or 3x. Whoops, go away. 3 goes into itself once, 3 goes into 6 2 times, 2 times x times 1. Here, the x's divide out, and I get 18, and I almost made a horrible mistake because I neglected to multiply the right-hand side by 6x. Boy, I'm glad I saw that. And that equals 6x. Combining like terms, I have 5x plus 18 is equal to 6x. Subtract 5x from both sides. I have 18 is equal to x. Problem finished. The third belt takes 18 hours to do this job by itself. All right, the last problems on the review come from the very last section. These have to do with complex fractions. And we had 2 types. Numbers 20 and 21 are what I believe I refer to as type 1, which is a single fraction over a single fraction. So number 20 asks us to simplify x minus 7 over 6 over x plus 5 over x. Well, when it is one fraction over one fraction, I rewrite it as a division problem. That is x minus 7 over 6 divided by x plus 5 over x. Keep, change, and flip. Now, I'm usually hopeful that I can do some reducing because this is a multiplication problem, but in this one, I cannot. So my answer, and I won't multiply it out, I'll leave it in factored form, is x times x minus 7 over 6 times x plus 5. If you did distribute, that would be fine, but totally unnecessary. This is your simplified answer. Let's look at 21. Same type problem. I have 4 over y over 7 over y plus 4. Because it is single fraction over single fraction, I change it to division. That's 4 over y divided by 7 over y plus 4. That's keep, change to multiplication, and flip. But nothing divides out. So I'm stuck with a similar question. On the top I have 4 parentheses y plus 4, and on the bottom I have 7y. Can't reduce it, no common factors. Now the last two are what I call type 2. These have pluses or minuses in the top and the bottom. So let's look at 22, and I do these a little differently. I have 5 over x plus 6 over x squared over, oh, there we go again, 25 over x squared minus 36 over x. You can see that there is the sum of two fractions on top and the difference of two fractions on the bottom. When they are more complicated like this, not single fraction over single fraction, I use a different technique. I find the least common denominator of all of the denominators, and I multiply the top by it and the bottom. The LCD is x squared. So I'm going to multiply x squared times this term and this term. That takes care of the top. This term and this term. That takes care of the bottom. So it's as if I've multiplied by x squared over x squared, which is 1. Now let's cancel some things. This fraction. This x divides out one of those, leaving one behind, and for right here, I end up with 5x. Second one, let's look here. The x squareds completely divide out, and I'm left with plus 6 over, let's look here, x squareds divide out, I have 25 minus, this x divides out one of those x's, and I have, excuse me, minus 36x. This almost looks like difference of squares, but that x is not squared. So I can't factor anything, so I'm done. Last problem, 23. It's still type 2 of the complex fractions. I have 4 plus 2 over x over x over 3 plus 1/6. Now remember, all you do is look at denominators. An x, a 6, and a 3. The least common denominator is 6x. So 6x times the top and 6x times the bottom. Let's reduce. Nothing to reduce there, so I have 24x plus x's divide out. I have 2 times 6, which is 12, over. Looking here, 3 goes in there once, 3 goes in there 2 times. I have a 2 times an x times an x, 2x squared. And the last one, the 6's divide out. I have 1 times x, which is x. I might be finished, but I think I can factor and reduce. I've not been able to do that in the last few problems, but I see a common factor of 12. 12 goes in there 2x times, 12 goes in there 1 time. In the bottom, I see a common factor of x. X goes in the first term 2x times, x goes into itself 1 time. 2x plus 1 is a common factor. That means that the simplified version is 12 over x. Now I know that I moved quickly through these problems, but you do have the ability to pause. I hope this helps you get ready. This was a long review, but I hope it helps you get ready for the Mod 7 Unit 2 test.